In this example, we will evaluate the indefinite integral of x times natural log of x plus 1. Now, we see that we have one of these desired forms for integration by parts, x times a function. And many times in that situation, we would let u be x and dv be the function. The problem is, if we look at the function that we have here, natural log of x plus 1, that would require a separate integration by parts to anti-differentiate. So what we are going to do is let the natural log of x plus 1 be u, so that the x will play the role of dv. So if u is the natural log of x plus 1, dv is the x dx, so that v is 1/2 x squared, and du is 1 over x plus 1 dx. And now we're good to apply integration by parts. So uv, 1/2 x squared natural log x plus 1, and we subtract away the integral of v du. I'm going to let the 1/2 from the v pull out in front of the integral, and then we're going to be anti-differentiating, in this case, x squared over x plus 1 dx. So we have applied integration by parts, and this difficult integral we started with, we've expressed in terms of this new and hopefully easier to evaluate integral. Now, to evaluate this integral, an observation that we can make is, well, integration by parts isn't going to really apply, at least not easily or in some obvious manner, but instead we see we have this inside function x plus 1, and that might lead us to think of making a substitution. Since I've already used the variable u, let's call it w. So if we let w be x plus 1, dw is equal to dx, so the dx would become dw. And the last thing we'd have to do is take care of this extra x that we have in the integrand. Looking at our substitution, though, we see that x is equal to w minus 1. So the first part here is going to come down for the ride, 1/2 x squared natural log x plus 1. And since we are going to always work on using good mathematical notation, we write the equal signs, we rewrite these first terms at every single step, so that we really do have a nice system of equalities. So minus 1/2, and putting this integrand solely in terms of w, the x in the numerator is going to become w minus 1. The x plus 1 in the denominator is w, and the dx is simply dw. So once again, the 1/2 x squared natural log x plus 1 gets carried down. Minus 1/2, and now in order to integrate this, we can just use a bit of algebraic manipulation. Kind of the ideal thing to integrate with respect to w would just be powers of w. So let's get it in terms of powers of w. W minus 1 quantity squared is w squared minus 2w plus 1. And this is all over w. And now that we have just this single w term in the denominator, we can break it up into 3 separate fractions. So we'll have the integral of w squared over w, which is w, minus 2w over w, which is 2, plus 1 over w. And now we are exactly where we want to be. We have an integrand made up of a sum of 3 different things, and all of them are easily anti-differentiated. So we have minus 1/2 times the antiderivative of w, which is 1/2 w squared, minus 2w plus the natural log of w. And our last step is to just resubstitute and get everything back in terms of that original variable. So each of the w's here need to be replaced with an x plus 1. So distributing that 1/2 through at the same time, we'll have minus 1/4 x plus 1 quantity squared. Minus 1/2 times minus 2 is just a plus 1. And then minus 1/2 natural log absolute value x plus 1, all plus c. And an observation to make here, just in general, Anti-differentiation is typically a much more thought-provoking process than differentiation. It's not nearly as systematic. So keep in mind that some of these problems may take multiple attempts until you find that correct approach, and you may have to use multiple methods of integration as well. Here, an integration by parts, a substitution, and some algebraic manipulation.